We have another terrific guest and an amazing show for you today. We are talking sustainability in space and orbital logistics. Welcome to the Tech and Space Leaders Show. I am your host, Lisa Dreher, and I'm really excited to introduce our guest for today, Erik Long. He is the CEO of Orbotic Systems. Welcome to the show, Erik.
Thank you, Lisa. I'm happy to be here.
Yeah, thanks so much for making time to be here. Maybe we can start by having you give a little bit of background on yourself and Orbotic Systems.
Sure. So, just at a real high level, my background is in economics and fintech, but also in space studies and aerospace science. So, a little combination there, hybrid approach. The company itself was started out of my master's thesis, which was on debris remediation. That's where the concept came from.
Great, great, great. So what was kind of the aha moment and the catalyst to starting Orbotic Systems?
Right. So I would say the original idea really started about 10 years ago. And so, going back to the thesis statement, so the idea there was that let's go ahead and do a deep dive into what space debris is and why it's important, and then do some technical review and analysis of if there's a way to solve the problem or if there's remediation abilities that we can develop. So it started there as just sort of a thought, and it continued to grow. There were numerous discussions with our co-founder Jane Elmini, who's also our COO now, and so before the company officially started, we were basically just bouncing ideas around, and then around 2019 and particularly 2020, we officially founded the company during the right in the middle of COVID. I think because we had more time to focus on it, and that's basically how it started. So I can go into more detail if you like, but that's the broad review.
Yeah, that's great. So talk a little bit about just this whole concept of orbital congestion and everything that's, I guess, happening within orbit for us and kind of where we're headed as well.
Right. So here's the thing that's interesting. So when we were first talking about space debris as an ongoing and developing problem, there really wasn't nearly as much talk about it as there is now. I mean, the idea that we would have thousands of satellites in orbit like we do now and growing would most people would have almost laughed at you if you said that. But now here we are with this huge amount of congestion that's growing, and the thing is that in order for these satellites to be able to operate, they have to be able to do it safely. And that includes everything through the whole ecosystem from investment capital that goes into the space companies to develop the satellites, and also to the services that these operators and manufacturers are trying to deliver as efficiently as possible. So, it doesn't take a whole lot for one satellite or one piece of debris to strike a satellite, create more debris, and then it cascades like a domino effect, and we could have a huge problem at different types of altitude regimes.
Yeah, yeah. How big of a risk do you really think the whole concept of the Kessler syndrome really is?
Well, we do a lot of work with NASA, and I mean, if you speak with some of the scientists, there's a handful that believe it's already started. I'm not in that belief pool, but I think we could easily slip into it if we're not too careful. And I mean, part of the issue also is that we have to have a collective agreement globally because each of these different countries is operating somewhat under different rules, and if we can't find a common ground to agree on how we're going to address or operate safely, then all it takes is one player in the game, so to speak, to do something that's not really helpful to everyone else, and it could cause a major problem. So I'm optimistic, cautiously. That's why we're in this business, but there's definitely an existing threat and danger.
Yeah. So talk a little bit about the approach that you are taking.
Okay, this is interesting because when we started the company, we ran across through a it was actually through a friend at NASA that had was just about to retire, and he turned us on to a technology that was being developed for deorbiting spacecraft before it, there's a problem with the craft becoming space junk. So, this is sort of the idea of mitigation instead of remediation. Is there a way we can address the problem before the spacecraft even goes up into the sky? So that was our initial approach, was that, okay, if we can essentially attach a device to a spacecraft before it's even launched, that at the end of the mission life cycle can be used to passively, without thrusters or without propellant, deorbit the spacecraft, then right there we're already ahead of the game. So that was the initial commercial product that we rolled out, and so that the name of that's D3, which stands for Deorbit Drag Device, and that's flown with the initial flight. The test flight was in 2022 on SpaceX CRS-25 mission, and it was deployed from the ISS, and it deorbited just fine. So that was the first approach, and then that sort of expanded into some other applications that we started focusing on. And I can go into those if you want. I don't know how much you want to
Yeah,
focus.
that would be great because so the D3, this is something that needs to be installed prior to launch, is that right?
Correct. That's the intention. Yeah, you just install it before it goes up.
Okay, and so then you have other concepts that you're working on as well?
Right. So this led. So you're dealing with a lot. Basically a lot of density, and without going into a lot of technical details, this density is a big part of what causes satellites to deorbit or change their trajectory, and this naturally led to space weather, and especially lately we've had some unusual space weather events take place, but it affects the density around the Earth. So I don't know if you recall, but a few years ago there were some satellites that dropped out of the sky that SpaceX had launched, and it was due to some unexpected space weather effects. But we ended up thinking that this is something this actually goes hand in glove with what we're doing with the deorbiting D3 system, and that led to what we call wind ion neutral density. It's a space weather sensor, and we were able to team up with NOAA to help develop that. So it's in the third year of development now, and we expect to have the prototype ready pretty soon by the summertime.
Wow, that's really exciting. So what will this enable?
So the idea is that you can measure ions and neutral particles, and you can do it faster and more accurately than it's been done in the past while the spacecraft is on flight. So this is designed to be on the spacecraft while it's circling the Earth and collecting the data. So what it allows you to do is not only take more accurate measurements that can be transmitted to, say, NOAA's Space Weather Prediction Center and use for their analysis to develop better forecasts, but you can also use it as a threat analysis on the spacecraft. So it can say, it looks like there's a density change that may affect the spacecraft electronics, so we want to shut things down. And that type of technology is very valuable. But also these density measurements can be used to make better forecasts in terms of where debris is moving to
Yeah.
or away from, and also the spacecraft. So they call that space situational awareness. So it helps that too.
Yep, absolutely. Okay, so what are some of the, I guess, newer capabilities that you're working on that will be available maybe soon or over the next couple of years?
Okay, sure. Well, there's a couple that we're really excited about. So, aside from wind, which I'm thinking that's already almost finished. So, but I'm still excited about it. But the we just entered into an agreement with the Aerospace Corporation, and when I say just, I mean we literally signed the paperwork last month, and it's for the manufacture and distribution of what's called the DISSat. So the DISSat is kind of a unusual, unique form factor and geometry for satellites. And I like to say to our team that hey, we just got into the flying saucer business. So because I mean, it literally looks like it is looks like a saucer. It's about 1 meter diameter, a few centimeters wide. And the nice thing about it is that because of the way it's shaped, it can move at lower altitudes through that density medium I was just talking about
Yeah.
more efficiently than a lot of these other satellites that have these strange designs to them. Because now you're talking about almost a combination of aerodynamics with spacecraft. So it's kind of a unique range. And it's closer to the Earth, and you can use it to collect different types of data that's not typically available in higher altitudes. So yeah, we're planning a Pathfinder mission on that. We're going to put our wind instrument on there, and our threat analysis software called Argus with it. We're also going to announce what we call DISSat as a service, which is an opportunity for people that want to fly their sensor or their subsystem on a DISSat to do it with us on different missions as they come along. So there's a lot of focus in our company on that right now.
Wow, that sounds amazing. So this is, I think, the whole idea of kind of debris removal or just mastering this congestion that is kind of coming coming toward us as maybe already existing, especially in low Earth orbit. How is the approach that you're taking really working to make this orbital, I guess, maintenance a commercially viable solution?
That's a great question, and I'm glad you mentioned commercially viable because the thing is that uh, as much as it's great to do experiments, and I mean I'm a proponent. I love that as well. We're a business, right? So we have to have a commercially viable solution that can generate income for the company. So the this kind of touches on the other new development that we're working on with NASA. So well, most of the approaches that I'm aware of that different companies that are trying or attempting to remove debris are using typically focus on one range of debris in terms of the size, shape, altitude. Also, they may use one type of an approach. So it's like the what I always see happen in a lot of these discussions is the giant elephant no one wants to look at or talk about is that a lot of these objects are tumbling, and they're tumbling in sort of a chaotic fashion. So it's not easy to go ahead and just say we're going to capture this. Uh, what we're doing right now is we're developing what we call riddance. It's a dual net capture system, and the idea is to use an initial net that's launched, not so much to capture the debris, but to control the tumbling action. So we're focusing more on tumbling as an initial problem. And then the second net that's released and tethered is the capture mechanism. So from our standpoint, that's the differentiator for our approach versus some of the other approaches out there.
Wow, that sounds really exciting. In terms of, I guess, the whole idea of ownership in space and some of the legal complexities of removing a piece of debris from space, how do you navigate that, especially as it involves like other nations or entities?
So I'm not the policy expert in the company. That's Jane, our COO. But I'm going to try and answer this as best I can, just from what I've heard her say on panels and discussions. So yeah, it's a major problem. It goes back to what we were talking about a little earlier. So how do you get everybody basically on the same page to agree to what's going to happen? Because you figure that each nation still claims ownership to whatever piece of debris it is. So you can't just go up there and let's say you had the best technology in the world that could easily remove a piece of debris. You still have to technically, legally have permission to capture it and remove it.
Yeah.
And there's for various reasons there's certain nations that may not want you to do that. So I think that we're moving closer to a general agreement. I mean, like for instance, we were talking about the D3 and the deorbiting once the mission is over. The FCC instituted what's called the 5-year rule, and that was in September 2024. And the idea is that you have to demonstrate before you launch how you're going to remove your satellite or your spacecraft once the mission is over, the life cycle is complete. And that caught on with a number of other countries, including the UK, European Union, New Zealand, Australia, Singapore, I believe, and I think there's a few others now. So it's, everybody's starting to realize that this affects all of the countries and all of the technology that's being utilized on the ground from space. And so I think everybody's starting to come to, trying to, they're realizing they need to come to some kind of common ground on how they're going to address this. So,
Yeah, absolutely.
yeah, it's like fingers crossed, but it looks like it's moving in the right direction.
Oh, that's good. Yeah, I mean, clearly, all of the nations around the globe need to be good stewards for generations to come, right? Hopefully, we'll be a spacefaring species for many, many, many millennia to come, right?
I hope so. Yeah,
So
barring the Kessler syndrome, we're good.
right, exactly, exactly. What role does the U.S. Space Force and Department of Defense really play in the growth of the orbital servicing market?
I think they play a huge role on a lot of different in a lot of different ways and levels. So what's nice to see is that Space Force number one, they're tracking thousands of different objects on orbit, and they're well aware of the problem of debris, so they're not ignoring that, and they want to protect their assets too, and so does other DoD agencies. The uh, the interesting part is that there's a bridge forming between Space Force and government and private industry, which I think is positive. So rather than the isolation that was probably the case in years past or decades past in the space industry, it looks like there's definitely a cooperative bridge that's building, and it seems to be getting even stronger. So I'm really optimistic about that.
Excellent, excellent. What do you see as the relationship between private satellite constellations, especially the mega constellations like Starlink and Amazon Leo that's going up, and the services that Orbotic Systems can provide?
Yeah. So what we rather than calling ourselves a sustainability company at this juncture, we call ourselves mission assurance because we feel that our technology stack actually is designed to assure that the mission is going to be completed. And so, as far as constellations are concerned, uh, and I think I mentioned to you before the show started that I was in D.C. and this came up as in conversation about space weather, and that's going to have a huge impact on all sorts of different constellations in terms of how it affects the the orbit of the constellations, the deorbit time, from the natural environment standpoint, and then also communications and the electronic subsystems on the satellites. So that's definitely a strong point for us. The debris removal with like we were talking about with Riddance and D3, I think those are fairly obvious. If the debris is out of the way, it helps the larger constellations, and and then also from the standpoint of VLEO, I'm interested in that personally, and so are members of our team, because it's an untapped region. Really, there are a lot of difficulties with it that I'm hoping DISSAT will help to solve. But getting a little bit closer and taking lessons that we've learned from previous years in LEO, I'm hoping that we can apply those to VLEO and help out a little bit as far as decluttering.
Right. So VLEO being very low Earth orbit?
Yes, very low Earth orbit. Sorry about the acronym.
No, no, it's all good. Okay. So I guess just kind of wrapping this up, what do you see as kind of the most common misconception that people have about space junk?
So I think going back to the tumbling, this is what I think most people envision space junk as just sort of these floating pieces of dead satellites or pieces that have broken off of them. And in fact, that's not the case. I mean, they're moving at 7 to 8 kilometers per second. So think about that, and the amount of energy that can be transferred from a collision is essentially from a piece of debris that would be like the size of your closed hand or fist, is definitely on par with, say, a hand grenade going off. So I don't believe, just from conversations I've had with people that aren't familiar with the subject, I think they just kind of envision that there's just this kind of slowly floating trash up there that you could just go and grab and move. But it's really a complex problem.
Yeah, yeah. Yeah, absolutely. Okay, so if someone wanted to learn more about orbotic systems, what should they do?
Oh, I would say go to our website or contact us. Our website is orboticsystems.com, pretty simple. And there's also, they can always send an email. You can send one to me. It might take me a while to get back to you, but that's el@orboticsystems.com.
Excellent, excellent. Well, thank you, Eric, so much for making time to be here today. We really appreciate it, and I feel like we've barely scratched the surface on this topic, so hopefully you can come back and visit us again.
Yeah, I'd like to. Thanks for having me. This was great.
Absolutely our pleasure, and I do want to take a moment to thank GuideForce for hosting these sessions. To learn more about GuideForce, you can visit guideforce.com. And until then, we'll see you next time on the Tech and Space Leaders Show.